Welcome back to For the Mariners by the Mariners channel. In the unforgiving environment of the open sea, a ship's structure is constantly subjected to massive forces that test the limits of its materials. To ensure a vessel remains seaworthy, engineers must master the principles of stress concentration and fatigue failure. At its simplest, stress is the internal force acting within a material, but it does not always distribute itself evenly. When a structural member has a change in geometry, such as a hatch opening, a sharp corner, or a weld defect, the stress lines cannot flow smoothly and instead bunch together. This phenomenon is known as stress concentration. These areas are called stress razors or notches, and they act as magnets for structural trouble. Imagine a flat steel plate under tension. If you drill a small hole in the center, the stress around the edges of that hole can be several times higher than the stress in the rest of the plate. In ship design, this is why hatch corners are rounded rather than square. A square corner creates a massive stress concentration point that invites cracks to form. While a single heavy load can cause a ship to bend, the most common cause of structural disaster is fatigue failure. Fatigue is the progressive and localized structural damage that occurs when a material is subjected to cyclic loading. Think of a paperclip. You cannot break it by pulling it once, but if you bend it back and forth repeatedly, it eventually snaps. A ship experiences this same effect every time it encounters a wave. As the vessel rides over a crest and into a trough, the hull hogs and sags thousands of times during a single voyage. This constant flexing means that even if the stress is well below the ultimate strength of the steel, tiny microscopic cracks can begin to grow at stress concentration points. Fatigue failure is particularly dangerous because it happens without warning. There is no large-scale deformation or stretching before the final snap. The process begins with crack initiation, usually at a weld or a sharp corner, followed by crack propagation, where the crack grows slightly with every wave cycle. Finally, the remaining intact metal can no longer support the load and a sudden catastrophic fracture occurs. To combat these forces, naval architects use SN curves, which are statistical tools that plot stress amplitude against the number of cycles to failure. This allows them to predict the fatigue life of various components. Proper maintenance is also vital, as engineers must use non-destructive testing methods like ultrasonic or magnetic particle inspection to find these hidden cracks before they lead to a hull breach. By reducing sharp angles, ensuring high-quality welding, and understanding the cyclic nature of the sea, we can prevent the silent threat of fatigue. It is the careful management of these invisible stresses that allows a ship to endure the relentless pounding of the ocean for decades. If you found this video helpful, please give us a thumbs up, hit the notification bell, comment, like, share, and subscribe for more insights. Thank you.